Welcome back to the number practice test part 2. This is for year 8 and for year 9. So year 8 to the first 6 questions, year 9 to all the questions. I think there are only 7 anyway. And the idea here is I will scroll through each of the questions. You pause the video, have a go, and go through to where you have to finish and check your work. And then if you keep rolling the video, I'll go back to the beginning and show you how to do all of the individual questions, and you can mark your work so you get an idea of what each one is worth. Okay, so let's start here. Pause it now and do question 1 and 2. Here we are, question 3 and 4. And question 5. Question 6 there. So year 8s can stop there now. And then question 7 with negative exponents. We'll do a few parts. And then the last few parts there. Okay, so pause it, go back and check your work and make sure you're happy. And now if you keep the video rolling, we'll go back and you can see the answers before your very eyes there, and watch me do some work. All right, here we go. First of all, put the name on the page here. Here we go. So name on the page. Now we have two numbers multiplied together, and what do we do here? They're both powers of the same base, so we're going to add the powers. 4 plus 2 is 6. Okay. Just check that you know why that works. Now, we don't want to go backwards all the time, but if you had, let's say here, 5 to the 4th would be 5 times itself, so there are 4 of them in a row there, and then times by 5 squared. 5 squared would be 2 5s multiplied together. So how many 5s have you got here? It's 6 of them, isn't it? Count them up. And we know that that index notation means this many 5s all multiplied together. So that's where the rule comes from. You don't want to go backwards all the time. We don't want to do this. But just keep in mind how the rules work. Okay, let's do the next one now. So here, look at the 4 marks. There's 1 mark for that answer only. Okay, so 6 to the 5th by 6 to the 6th is 6 to the 5 plus 6 is 6 to the 11th. So there's 1 mark for that. Okay, A by the 5th is a bit tricky because A means A to the 1, doesn't it? Only 1 A sitting there. So that's not written. So that's a bit tricky. So it's 1 plus 5 is 6. Okay, and 1 mark for that. A cubed by A to the 7th is A to the 3 plus 7, which is 10. Okay, so did you get 4 marks for that one? Let's come on down here a little bit and have a look at question 2. So in question 2, it's 3 to the 9 divided by 3 squared. And here we will subtract the powers. 9 take 2 is 7. Just remember why that works. If we had, and we'll put it over here somewhere, if we had 3 by 3, and there were 9 of them in a row there, well, 9 of them, we won't put 9 on the end, we'll put 9 here, and we were dividing by 3 squared, there would be 2 3s times there. And we could start to cancel, couldn't we? Divide top and bottom by 3, goes once into each of them, and next 3. And how many would you have left here? You've cancelled out 2 of them. So you would have the answer 3 to the 7th. That's how come the subtraction rule works for powers when you're dividing 2 numbers. So there's 1 mark for that. So we don't want to go back to this again. We don't want to go back and do it all in longhand. We want to use our index notation to advantage. So that's why we have our rules to remember how to do it more easily. So let's look at this one now. So 7 to the 13th on 7 to the 9th. 9 of these would cancel out 9 in the top line. So it'll be 13 take 9 is 4. Okay, so there's our second power or index law. 5th to the 7th divided by 5th to the 4. Well, if you like, you could put it like this. 5th to the 7th over 5th to the 5 to the 4, sorry. And here you would subtract the exponents again and get 7 take 4 is 3. So there it would be. Okay, a to the 8th over a to the 3 would be a to the 8 take 3 is 5. Just remembering here that a is standing for a number. And as long as a isn't naught, it makes sense. A can't be naught because you can't divide by 0. So you can't have an a which is 0 down the bottom line, because division by 0 isn't defined in mathematics. You can't split something up into no parts. So here you're going to use a bit of algebra, remembering that if you have a letter, it's standing for some missing number, that's all, and you can do with a letter exactly what you would do with a number. So that's the idea there. Okay, so I hope you're getting some marks here. Okay, so there's one for each of those. Let's come down to question 3. Now, question 3 is another rule where you've got 2 to a power, and then you've got all of that raised to another power. So what does that mean? Before I use the rule, I'll show you here. 2 to the 9th squared means 2 to the 9th times itself. So how many 9s would you have? Well, this goes back to the original rule of multiplication. You'll add the powers or indices. So it's 2 to the 18. Now again, we don't want to go back and reinvent the wheel. So what have we actually done? To get that most quickly, we will multiply those powers together, 9 times 2, to give 18. So there's one mark for that. Here's another one the same. Now, how many 3s would you have if you cubed 3 to the 7th? There'd be 3 to the 7th times 3 to the 7th times 3 to the 7th. There would be 21, wouldn't it? So we're going to start just using the rule of multiplying these powers together, because that's the quickest way, rather than going back and reinventing our whole system again. So this one here is 5 to the, multiply those two together, 28. Okay, and here a just stands for any number, and so it's a to the, multiply these two together, a to the 12th. So we've invented or created a new system here of condensing down messy repeated multiplications. We call it the index law. And we have a neat system, as long as you can remember what it all means. It's important not just to use rules, but to understand why they work. So here we have 4 marks. I hope you got some of those. Now, simplify. 4 to the 0. 4 to the 0 shouldn't make sense, should it? But we know any number to the 0 is 1. How does that work? Well, how would you get 4 to the 0? 4 to the 6 over 4 to the 6. According to the rule, we would subtract those powers, 6 takes 6. And so according to our division rule, which is subtraction of exponents, it is possible to create this strange creature called 4 to the 0. And what would it come to? Well, a number divided by itself comes to 1, doesn't it? So when we have 4 to the 0, it means all the numbers in the top line of the fraction have cancelled out with the numbers in the bottom. You've got 0 power, and it comes to 1. Okay, so the answer is 1. And 5 to the 0, it's the same thing, 1. And 12 to the 0, same thing, 1. 2 to the 0, oh, this is a bit different. 2 to the 0 is 1, plus 2 squared is 4. So the answer is 5 to that one. 1 mark for each of those. So just going through slowly and carefully, remembering the rules and hopefully remembering how it works as well. So come down now to question 5. Now we're doing some division here. What's the difference with this one? Well, there it is. It's b. Now, b means b to the 1. So this is subtraction of powers. 4 take the 1, which is unwritten, is 3. Okay, remembering that b, any letter in mathematics, is standing for some missing number. Okay, so there is 1 mark. Now, we've got a different sort of problem here. We've got two terms multiplied together. They've both got numbers in them. So number multiplication stays the same. 3 times 5 is 15. With our powers, our little index notation, our shorthand way, if we multiply c squared by c cubed, it'll be c to the 5. Okay, so you'll be adding the powers. All right, so there's 2 marks here. Those two, okay. And let's go again here with this little one. Can you see you've got A's and B's? So you've got to keep them separate because they mean different numbers, don't they, A and B? So let's do the A's. If we had A cubed, and let's just rub that out because I've messed it up there. This is A cubed on A to the 1. Splitting it up, times b squared on b squared. So let's do the a's first. So here, that's a squared. Don't forget a is a to the 1, times here b to the 0, if you like, or just 1. A squared by 1, or just a squared. We should put in the proviso here. Proviso, provided that b is not equal to 0. Because any number raised to a power 0 is 1, except if that number is 0. Because, look up here, because if we had 0 to the 6 in the bottom line there, you can't do that problem. You can't divide by 0. So you just should put that proviso, PV, provided that b is not equal to 0. I won't penalise you for that one here. Okay, so there's 1 mark for that, and 1 mark. I'll let you leave it at b to the 0, but that should go to 1. You should have a squared. Okay, so let's have a look at the last one. Same thing, let's split it into the parts. It's the number part times, well, the given number part divided by the missing number part, if you like. So it's d to the 8 over d cubed. Now, numbers are still unaffected by these rules for indices. 3 into 18 goes 6, so we do that. And then d to the 8 on d cubed, you subtract the powers. 8 take 3 is 5. So you've got to remember that the ordinary numbers, 18 and 3, behave as they normally would. They don't change here. Just the index laws that are new. So we have 2 parts, the number part and the power part. So there are 2 marks there. So we've got a total for that question of 7. How are you going? I hope you're getting some marks there. So come back and check it later if you're missing out on some of these. So this is question 6 now. And this is where year 8s can stop because that's all that's in the course there. So we have the final rule now, is all of that squared. So you have to square each of them. The 3 squared will be 9. And then a squared squared, you know the rule for that. Multiply the powers together. Okay, a to the 4th. So don't forget, the squared applies to the 3 as well. So 9a to the 4th. Now I'm going to give you 2 marks, 1 for that and 1 for that. Okay, let's look at the next one. Remembering now, see the bracket? Remember bed maths, do the bracket first. So it's 2 raised to the 4th and p squared to the 4th, which is p to the 8. And q, remember q is q to the 1. Q to the 1 to the 4th. 1 times 4 is 4. Okay, so that's our answer for that one. And again, there's a fair bit of work there. There's 1 for top and 1 for bottom, if you like. Okay, let's look at this one. We've got to do everything in there to the 3. So this is 3 cubed. C is c to the 1. All to the 3. 1 times 3 is 3. and d to the 4 times 3 is 12. So I'll give you a 2 for that. If you get any one of those incorrect, then you lose 1 mark. And if you get 2 incorrect, even if you get 1 right, you lose all marks. So it's 2 for that, and 1 mark off for any error. It would be good if you could write that as 27, but that's all right. Okay, here we go. A to the 4th squared will be a to the 8th over, got to do 3 squared is 9, n to the 1 squared is n squared, and, oh sorry, n to the 7th, I've missed that, n to the 7th, and that is squared, so it's n to the 14. So 1 for the top, 1 for the bottom. Okay, total this time of 8 marks. All right, so that's the end of the year 8. So total it up and see what it comes to, and then we'll see how you went overall. All right, let's have a look at question 7. And question 7 has got many parts. So here, what are we going into? Negative exponents. And that means the reciprocal, or 1 over 5 to the 1. Okay, the negative part of the exponent means reciprocal. Do you remember why that happened? Let's have a look. What if you had 5 squared over 5 cubed? What would that be? Be 5 squared over 5 cubed, so we could cancel here. That goes once, 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 once. So this comes to 1 over 5. Okay, and if you use your power rules, 5 to the 2 take 3. Oh, that's how you get a negative power. We thought that was a bit strange, but you get a negative power on division when there are more of the numbers in the bottom line or in the denominator. That's how come we say it's the reciprocal. Okay, negative power means when you've cancelled them, you've got a negative number because there were more 5s in the bottom line. So it means what's left is in the bottom line. So it's the reciprocal. So this one, 4 to the neg 1, is 1 over 4 to the 1. 8 to the neg 1 is 1 over 8 to the 1. 10 to the neg 1 is 1 over 10 to the 1. And 3 to the neg 2, watch it, is 1 over 3 squared. There were 2 3's left in the bottom line that didn't get cancelled. Okay, or 1/9 here. So here, the idea is to have 1 mark each, just 1 mark for each of these. Okay, and you can go to 1/9, or you could just put that. It'd be better to have 1/9, but we won't penalise that at this stage. Okay, so how did you go there? Let's go down and have a look at the last few parts here. 3 to the naught, mixing it up now, plus 3 to the neg 1. 3 to the naught is 1, plus 3 to the neg 1 is 1 over 3. Okay, so you could call that 1/3 or 4 over 3. Okay, as a mixed number or as a fraction. So here, the marking here is 1 for each of those. 5 over 6 to the neg 2. Now, what's this mean? Okay, we'll better do the negative first, which means 1 over 5 over 6 squared, doesn't it? Remember the negative, do the negative first, which means reciprocal, 1 over. And so let's work that out, 1 over, and squaring 5 over 6, square the 5, 25 over 36. And now, 1 divided by a fraction, you invert and multiply. I hope you've been taught why that is so. Okay, you might ask your teacher, talk to your classmates about that. Division by a fraction, you multiply by the reciprocal. You turn it up that way. So the answer is 36 over 25. It's a lot of work for that one. So the answer here, you'll get 1 for the top line, 1 for the bottom line. Okay. Or if you got to this point, you'd get a 1 mark for showing that you knew the negative meant the reciprocal. All right, let's have a look at this one now. Now this one would be better off if you called this 2 times 4 is 8, which is 9 over 4 for 2 1/4. Make it a single fraction, and then we're raising it to the -2. Okay, so let's do that again. Let's do the negative part first, which means 1 over 9 over 4 squared, which you want to turn it up the other way first, maybe. 1 over 9 over 4 is 4 over 9 squared. You could do that part first. It doesn't matter. You can square it and then invert it, or invert it first and then square it. So 16 over 81. Okay, is our final answer there. All right, so I think we will give 1 mark for knowing that it's reciprocal, and then 1 mark for the answer, something like that. You can see the idea of the two things we're looking for there. The negative part to know that that's reciprocal, and then to square it. Okay, well, let's look at this one here now. 2/3 to the negative exponent. So let's invert the 2/3 for a start. We'll do it that way. So make it 3 over 2. Go straight to that. That's not too fast for you, is it? We've just reinforced here with those those last two problems here that if you have a negative, it means reciprocal, and the reciprocal of a fraction would be 3 over 2. Okay, so we go straight there. And we're going to cube it, so it's 3 cubed over 2 cubed. And then we've got, therefore, 27 over 8. All right, so usually what we'll do here would be to say, well, 1 for realising that the 2/3 to a negative power will become 3 over 2, and then 1 for the answer. I think you should go to 27 over 8. It's not clear in this question. I've forgotten. Let's just go back up to the question and see if we can just come here and see if what did the question say? In simplest rational form. Simplest rational form means we do want these answers here to be worked out. Simplest ratio in our form, ratio. So it's the simplest rational form, simplest fraction form is multiply it out. So you really do need to do that step. Okay, let's have a look at this one up here. 5 to the 0 is 1, plus 5 to the 1. Take 5 to the -1, negative power means 1 over 5 to the 1. Now, these are all adding and subtracting, so they are behaving like ordinary numbers now. We've done the power parts. So 1 plus 5 is 6. Take 1/5 is 5 and 4/5. Okay, 5 and 4/5. And we've got to put that in the simplest rational form, which means fractional ratio of integers. So 5 5s are 25 plus 4 is 29 over 5. That one is a fair bit of work. So 1 mark for really understanding what the exponents or indices or powers mean there, and 1 mark for the answer. Okay, so that's a fair bit of work for those 10 marks. All right, so we're nearly at the end here, so we'll just come down and look at the last 4 parts. Okay, so here we are. Let's have a look at GH to the -3. Okay, so we want this in the simplest form. So that's G, or just G to the 1, times H to the -3, means 1 over H to the 3. So that is G over H cubed. Okay, so 4 marks there. 1 mark for realising you have to use a negative exponent on that H, which is the reciprocal 1 over H cubed, and 1 for putting the two together. What about this one now? it's all in a bracket raised to the -3. So that means it's g to the -3 times h to the -3, which would be 1 over g cubed by 1 over h cubed, which is therefore, remember timesing fractions here, 2 numerators times 2 denominators times. So g cubed by h cubed. So 1 for the conversion, well 1 for, I suppose, this one, for showing that you know you have to raise both terms to the -3, and 1 for the final answer. Okay, it's the simplest rational form, so this won't do. You have to go to here and make a single simple rational form, a simple fraction. Okay, so 4 marks there, and let's have a look at the last one now. So 4c, do this first. D to the negative means 1 over and square it, 1 over d squared. So what's that mean? These are in the numerator, top line of the fraction, and the d squared, because the negative power has gone to the bottom. So there's 1 for the top line, 1 for the bottom. Okay, so if you left it at this stage up here, then you would get 1 mark because you put 1 over d squared, but you haven't put it together as a single rational form or simple fraction at the end. Okay, let's do this one. It's 4 to the -2. We've got to do each of these raised to the power because it's all in a bracket. C to the -2 and d to the -2. So what does that mean? This is 1 over 4 squared times 1 over c squared times 1 over d squared, using the idea of the negative power meaning reciprocal. Okay, so there's really quite a few marks here, and there should be another mark for this one. But anyway, it's 1 over 16 c squared d squared as the simplest rational form. Okay, so I reckon there's 1 mark for that. There really should be 1 mark also for showing that you've applied the negative power to everything in the bracket. But anyway, we'll start the mark there, and then you would do this. And it should be 16 here. If you didn't get 16, don't get that mark, because the simplest rational form was not 4 squared, it would be 16 for ordinary numbers. Okay, so there we have it. See what your total is. Now, we'll just total these up and go back slowly and see what the total should have been. 4, 8, 18, 23, 31, 38, 42, 46, 50, 54. Yes, I knew that was wrong. 54, it's not 35. I put more on there in the end. It was 54 marks. Okay, so you might just check those additions there and see what you got. All right, so I hope you're happy with all of that. Now, to get ready for the proper tests at each year level, you need to go back over this and make sure you understand all the rules. All right, well, good luck with the proper test. Cheers for now.